Area of a rectangle or square, we multiply length times width. So we're going to do 12 times 22.
264.
Thank you. And it's square feet. Area of a triangle is 1/2 base times height. Or you could say base times height and divide it by 2. Same thing. So I have 4 times 4, which is 16. And half of 16 is 8 feet squared. The following, and we need to use our order of operations. Okay, so we're going to do what's inside the parentheses first. So this is first. So 2 times -1 squared plus 6 minus 5 times 8 minus 3 squared. And next I'm going to square my numbers because exponents come next. -1 squared is 1. 3 squared is 9. Yeah, right here, -1 squared.
That's if the exponent is outside of the.
Yeah, if you have this, it's that. If you have this, it's that. Because this negative is not being squared unless it's inside parentheses. That's why I left it in parentheses when I did the subtraction. Whereas this 3, that negative's not in the parentheses, that's why it's -9. Then I need to combine those. 1 plus 6 is 7. 8 minus 9 is -1. Then I multiply 14, and then -5 times -1 is +5. So my final answer is 19. Okay, so we're rounding the following. We're going to round this to the 10th place. The 10th place is right here, which means it's right there, which means we need to look at that number. So this is 26.3. The 1000th place is right here, which means we need to look at that number. So 0.007. 100th place, so 0.02. Okay, we have more order of operations, but with some absolute value in there. Same idea though, we still need to use PEMDAS. So I'm going to do what's inside the parentheses first. Absolute value also counts as a grouping symbol. So this is going to give me -3. And 9 minus 20 is -11. Then I square this. That's 9. And then the absolute value of -11 is 11. So this is 20.
Well, that's sad.
Okay. Here I have 9 minus 5 and 11 plus 12. 9 minus 5 is 4 squared minus the absolute value of 23. 4 squared is 16. Absolute value of 23 is 23. And that negative is just, hanging out. So I have 64 minus 23, so that is 41. Okay, so we're going to simplify here. I need to square first. Okay, so if I'm squaring 3/5, I square the top and I square the bottom. Then I need to change this division into multiplication, so I copy, dot, flip. And then if you want, you can cross cancel. Otherwise, you can multiply across and reduce. And you get 25 over 11, which doesn't reduce any further.
Could you make it a mixed number?
You could make it a mixed number if you wanted to. It would be 2 and 3/11. But it's multiple choice. Next, I'm going to square this first. So that's going to give me 16 over 9 times 1/2. If I want to reduce, 2 goes into 16 8 times. Otherwise, I can multiply and then reduce. And I get 8/9. So we can't multiply these as they are. We have to convert them to mixed numbers, improper fractions. So I'm going to multiply and add. So 2 times 2 is 4, plus 1 is 5/2. 4 times 3 is 12, plus 2 is 14/3. And if you want, you can cross cancel the 2 and the 14. And you end up with 35/3. And if you wanted to, you could put that into a mixed number and you get 11 and 2/3 if you did do that.
We don't have to put it.
No. Well, it depends on
If the question
what the
asks for
multiple
it.
choice question asks for.
Gotcha.
This would be fine for most purposes.
Okay.
Same again. 3 times 1 is 3, plus 2 is 5. And it was negative there, so it's negative here. 4 times 3 is 12, plus 3 is 15. I can cross cancel the 3 and the 15 if I want. So I get negative 25/4. And negative times positive gives me negative. Or that's going to be 6 and 1/4, also negative.
But wouldn't that make the whole equation?
We have a car that can go 213 miles on 9 gallons of gas. So we want to find the miles per gallon. Miles per gallon, per means divide. So you divide miles by gallons. So I'm going to do 213 divided by 9. Okay.
23.7.
Yeah?
Yeah.
23.7. So it's going to get 23.7 miles per gallon. Okay? If gas is $398 now. $3.98 per gallon. How far could you go on $20 worth of gas?
So you have
So you-
Divided by 3.9.
Yeah, so you take your $20 and you divide it by 3.98 to find out the number of gallons you can buy.
Multiply that by the APG.
20 divided by 3.98. I can buy 5.03 gallons. And then to find the distance, I'm going to multiply my gallons times my gas mileage.
Are we supposed to do that?
Uh-huh. And that tells me I can go 119.2 miles.
Okay.
I want that. Every day.
What model was it again?
To turn a percent to a decimal, I move 2 places to the
Right.
left.
Left.
Right? So if I'm here, I'm going to go 1, 2, and that gives me 0.26. And if I'm going to turn this decimal into a fraction, I'm going to put it over 100. 13 over 50. If I'm going to put this decimal into a fraction, I'm going to put it over 100. And both of these will divide by 4. So I get 8 over 25. Or you could divide by 2 and then divide by 2 again. To turn a decimal to percent, I move 2 decimal places to the right. So it's 32%. Okay, to turn this fraction into a decimal, I divide 2 by 5, so I get 0.4. So my decimal is 0.4.
That's what I thought.
And then turn that to a percent, I go 2 places to the right, so 40%.
Okay.
This is one of those formulas you guys might want to put on your one page. Just, you know, throwing that out there. Bless you. Bless you. It's the wind. It kicked up all the dust and the pollen and everything.
I like cold weather. Why is it inch or inches?
Inches.
Right?
Yeah, inches. Here, I'll make that a little better. That'll probably be easier to see. Okay. I don't like the cold.
Is it multiple choice?
Yes.
So how does it spell in inches?
Because area is always squared, and this is just like a perimeter, so it's just a straight distance around the circle. Does that make sense? Okay, everybody got this one? All right, next. Oh, I was recording that whole time. Okay, next we have comparative between decimals and fractions. You can either convert your decimals to fractions, or you can convert your fractions to decimals. Whichever one you find easier. If I convert 2/3 to a decimal, that's going to be 0.6 repeating, so basically 0.7. So that's less than 0.8. If I convert 0.8 to a decimal, it's going to give me 8/10, but then I'm going to need to find a common denominator, which would be 30. So I would get 20/30ths for my 2/3 and 24/30ths for my 8/10, so it would still be.
I like decimal.
Can I ask you something?
Sure. Decimal. All right. Integers. Anything that is not a fraction, a decimal, or a radical once it's completely simplified is an integer. So 4 is an integer. 2.6 is not. 1/3 is not. The square root of 5 is not. -16 is. 1/4 is not. 0.284 is not. But the square root of 9 is, because the square root of 9 is equal to 3. Yeah, square root of 5. Here, I'll rewrite them.
Why is 5 not an integer and not a base?
Well, okay, this is the square root of 5, right? But I can't simplify that. But the square root of 9 actually equals 3. And
So-
3 is an integer.
So would you state the definition again of an integer? Yeah, there you go.
Okay, so like if you had a fraction like this, 24/3, that actually reduces to 8. So it's an integer.
You can work with that.
If you can reduce it and get a whole number out of it, so the square root of 9, if I actually take the square root of 9, it's 3. That's a whole number, so it's an integer. But the square root of 5, I can't, if I put that in my calculator, I get some decimal forever, right? So it's not an integer. So no fractions, no decimals when it's completely simplified.
5 is 2.236067977.
Yeah, then it keeps going. You just don't have enough room on your calculator. So, but you see what I mean? So if it doesn't give you a integer, when you simplify it, it's non-integer. I mean, if it doesn't give you a whole number. So no decimals, no fractions. Okay, if I just change the order, commutative. I can't tell you that. If I multiply something in like this, it's distributive. Here, if I only move the parentheses, but everything's in the same order, it's associative. And here, if I divide the same thing out, that's also distributive. Right? It's like this, exactly like this, but backwards. Prime factorization. Make a factor tree. Okay, so the prime factorization is the end of all the branches. So you have 2 times 2 times 2 times 3 times 5, right? 2 times 2 times 2 times 3 times 5. Or with exponents, 2 to the third, because there are 3 2's, times 3 times 5. This is 5 times 45, which is 5 times 9. So that's 5 times 5 times, oh, whoops. Ah, yeah, see, getting ahead of myself. 3 times 3, so this is 5 times 5 times 3 times 3, which is 5 squared times 3 squared. This is 2 times 720, which is 2 times 360, which is 2 times 180, which is 2 times 90, which is 2 times 45, which is 5 times 9, which is 3 times 3. So there are 1, 2, 3, 4, 5 2's, 1 5, and 2 3's. But we would probably actually put the 3's first. Yeah, 2 and 3, 5. 2, so 2 times 3 squared times 5. Yeah, lowest to highest. Okay, evaluate. This is negative 6 times 6. So that negative is hanging out. So that's 36, and it's a negative 36. This is negative 6 times negative 6. So that's a positive 36. And this is a negative with a negative 4 times a negative 4. So that's positive 16. But that negative's hanging out. So you get negative 16. So any negative that's not inside the parentheses is a lurker. Lurker, lurker. Again, with some more absolute value, so I do what's inside. So 4 minus 6 is negative 2. 15 minus 9 is 6. Then I take the absolute value of those numbers. The absolute value of negative 2 is positive 2. And the absolute value of 6 is just 6. And then I multiply that by negative 2, so I get negative 12. And 2 minus 12 is negative 10. All right. Translate 5 more than. More than means adding. So this is 5 more than 3 times. That's multiplying. And anytime they say a number, it's just some letter. So 5 more than 3 times a number. Okay, if we say 4 less than, that means this right here, that means minus 4, not 4 minus, right? Okay, the product of 2 and a number, so 2 times a number, and then minus 4. Now here is where I've seen mistakes. This is 12 times a number and 5. And means plus, right? 12 times a number, 12x, and then and 5. Okay. Sometimes people do, I'm going to do it in blue because it's wrong.
Mm-hmm.
12 times a number and 5, but this is actually, this right here would be 12 times the sum of a number and 5. Okay, so that's the difference. This is saying 12 times the sum. That's when you put it in parentheses. This is just saying 12 times a number and then add 5 to it. Okay, so I don't want to see that mistake on the final.
Okay. Dudes all night.
No. Okay, we're going to convert 4 yards into inches. Okay, so I have 4 yards. And if you don't know how many inches are in a yard, that's okay, because you can say there are 3 feet in 1 yard, and then there are 12 inches in 1 foot. And then my yards are going to cancel, and my feet are going to cancel. And I'm going to do 4 times 3, which is 12, times 12. So I'm going to get 144 inches. Okay, if I do 780 inches into feet, I start with inches. And there are 1 foot over 12 inches, right, so that my inches cancel. So that's 780 divided by 12. Is it? Okay. So that's 65 feet. And if I want to turn 2 weeks into hours, I know that there are 14 days. No, sorry, that's in 2 weeks. Silly me. Yeah. 7 days in 1 week. Bless you. And then there are 24 hours in 1 day. So my weeks and my days will cancel, and then I multiply 2 times 7 times 24, which is 336 hours. Of means multiply, right? So this is, first convert that to a decimal, times 1200. Did I say 12,000? I meant 1200. So 0.23.
276.
Okay. So that's 276. Okay, here I have 15% of what number? So first I'm going to turn that into a decimal, so it's 0.15. Of is multiplied. What number? I don't know, so that's x. Is equals 12. So I'm going to divide both sides by 0.15. So if I divide 12 by 0.15,
0.0125.
no, it'll be bigger.
Oh, I did it backwards.
You're doing 12 divided by 0.15.
80.
Yeah, so x would be 80. And then here I have 20 is equals what percent? I don't know what my percent is, so that's x, right? Of 480, that's multiplying, so I have 480x. So I'm going to divide both sides by 480. So 20 divided by 480 is
480.
Yeah.
Oh, that's what it was. And when I round it,
Give me like 3.
.04116. So.
What's the one after the 6?
.042.
Okay. All right, so I have 0.0, so I'm going to turn that into a percent, so I move 2 places, so X is 4.2%. Okay. All right. If the property tax on a $200,000 house is $2,400, what is the tax on a $350,000 house? This is a proportion. So we have tax over house is equal to unknown tax over house. Or you could do house over tax is equal to house over tax. Just remember you have to do the same thing on each side. So then I'm going to cross multiply. But actually, I'm going to reduce before I cross multiply because I like to multiply by smaller numbers. So if I cross out those 2 zeros, I can cross out these 2 zeros. Right? And then I can do 24 over 2,000 if I want to, but I'm just going to do the easy reducing, and I just crossed out the zeros. So I have to do 350,000 times 24, which is 8,400,000. So 2,000x. Oh, geez. I'm just going to double check my number of zeros. I should have 5, okay. All right, and then I'm going to divide both sides by 2,000. Okay, so you'll have, I want to look at it later. Okay, I'm going to distribute my 2. So we get 2x minus 12 is equal to 4x plus 10. I'm going to move all my x's to one side and all my numbers to the other. And just for simplicity, I'm going to move all my x's to the right. Left, right, left, left.
What?
I add and subtract. I don't know right from left, whatever. So I'm going to get negative 2x minus 12 is equal to 10. Right? I just moved the negative 4x over. And then I'm going to add 12 to both sides. So I get negative 2x is equal to 22. And then I'm going to divide by negative 2 to get x is equal to negative 11. I have a fraction times an x. Whenever that happens, multiply by the denominator. Because if I multiply the denominator, it clears the fraction. And you're left with the numerator, in this case a 1. But if I have a 1, it's the same thing as not having anything. If this was like a 2/3, I would be left with 2x, and then I could divide by 2. Okay. And then the numerator stays, and then if the numerator is an actual number that counts, you would divide by that. Like if I had 2/3 x is equal to 6. I'd multiply both sides by 3, so I get 2x equals 18. Then I have to divide by 2, yeah.
Gotcha.
Next, simplifying, we distribute. Okay, And then we collect like terms. All of these match, so I'm going to add them up. 3x plus 4x is 7x. Minus 2x is 5x. And then these match, so I'm going to add those up. Negative 18 plus negative 10 is negative 28. These don't match, so I'm done. I'm going to distribute this negative 4. And don't forget the negative has to stick to the 4. So when I distribute, I'm going to get 6x minus 8x minus 20, then minus 3 plus 2x, because that was just already there. These match, so 6 minus 8 is negative 2x plus 2x gives me no x's. And negative 20 minus 3 gives me negative 23, so really this is just negative 23, right? Because no x's means no x's. Next, evaluate. X equals 2, so I'm going to replace x with 2. Y is negative 6, so I'm going to replace that. And then z is 5, so I'm going to replace that. So what I'm going to end up is with 5 times 2 plus 2 times negative 6 minus 7 times 5.
Question.
Yes?
It might be silly, but why do they throw in the 5x, 2y, 7z, and then just give us all of those?
It's so that you can learn that these are equal concepts so that you can transplant, like you can replace them with each other. It's going to be useful later. It will. It'll be useful later. So this is 10. This is negative 12. This is negative 35. What's the, here?
And Z?
Z. Yeah. So 10 minus 12 is negative 2 minus 35, so negative 37. This one might have been in chapter 8, but it showed up on the final converting from Celsius to Fahrenheit. Okay, this is if you have Celsius and you want Fahrenheit. Okay? This is if you have Fahrenheit and you want Celsius. So I have Celsius, I want Fahrenheit. So I plug in what I have for Celsius. And what I'm going to do, because it's easier, is I'm going to convert 9/5 to a decimal. Because 5 didn't go into 42 evenly. If 5 had gone into 42 evenly, I would have just left it as a fraction because that's actually easier. But here it didn't work that way. So I do 42 times 1.8, and that's going to give me 75.6 plus 32. Okay, so 42 degrees Celsius is the same as 107 Fahrenheit. Now here I have Fahrenheit, and I want to turn it into Celsius. So I plug in 81 for the F. Times 113. Now 9 does not go into 113 either, so I'm going to do 5 divided by 9. Okay, and then I'm going to multiply that times 113. And I'm going to get 62.7. That's not right. That's not right. Hold on. What did I do wrong? 5 divided by 9. Okay, 81 degrees Fahrenheit shouldn't be 62 degrees Celsius if 42 degrees Celsius was 107 Fahrenheit.
Right.
So hold on.
Is it the 5/9 thing?
1.8.
Fahrenheit was 1.8.
I might have written down the formulas wrong. Hold on. They're on the test. Okay, so sign errors make a big difference, right? So that's minus 32, so that's 5/9 of 49. So it's 0.5 repeating times 49, which is, oh, you didn't do, okay. So times 0.5, 5, forever, whatever. So it's about 27.2 degrees Celsius. And again, though, these formulas are on the test. So you just have to plug in. If they give you Celsius, you plug into this one to get Fahrenheit. If they give you Fahrenheit, you plug into this one to get Celsius. 5 divided by 9. It's 0.5 repeating.
One last page.
One last page. Fractions! Yay! What's my common denominator between 2 and 3?
Are you recording?
Yes. I think so. Yes. Okay. 6. So I'm going to multiply this by 2 and this by 3. So I get 4/6 minus negative 3/6. But that's positive. So it's 7/6. Between a 5 and a 6, my common denominator is 30. So multiply these by 5 and that one over there by 6. You get 24 over 30 plus 5 over 30, which gives me 29 over 30. Common denominator between 4 and 3? 12. So multiply this one by 3s, this one by 4s. 3/12 minus 4/12. Yeah, negative 1 over 12, right? Because 3 minus 4 is negative 1. And here, my common denominator between 3 and 9 is 9. So I only have to change one of the fractions.